Now, ice is also a very interesting substance in its own right. Solid water. There's a very unusual property of solid water, and that is that it floats on top of liquid water. Well, you might think nothing very exciting about that. We all know that ice floats on top of water. After all, icebergs float. But actually, it is very unusual. Here we have some solid cyclohexanol, and we've just added this to the liquid cyclohexanol, and this one actually sinks. In fact, this is the usual case. It's more normal for a solid substance to sink when we put it in its liquid. It's actually very unusual that water floats when it's ice on top of liquid water. But nonetheless, it's a good thing that it does, because this means that when temperatures drop, and if we've got to have a pond filled with water, the surface freezes, but rather than that ice dropping down to the bottom and then more ice forming and then that dropping down to the bottom and the entire pond freezing, it means that only the top freezes and the ice floats on top, which means underneath it's insulated from the cold air by the layer of ice above, and so the fishes can still survive, which is great. Okay, it'd be bad for fishes if ice sank. Okay, now, we'll come back to exactly why ice floats, but we've got one more demonstration to show you involving this, and I need to come over here. And I have a metal container here made of cast iron, and I'm going to fill this now with water. So we'll fill this up. So this is now filled with liquid water right to the brim. This is made of, let's say, cast iron, so it's pretty strong. And I'm just going to do this up completely, so it's really tight. So at the moment then we've got the container filled with liquid water, but in a minute I'm going to freeze this to turn the liquid water into solid water, into ice. Now we're going to lower the metal container here into this bath in here that contains a very, very cold liquid, so this is going to freeze the water. But as you've seen, as we freeze the water, well, the ice takes up more space than the liquid form. So I'm going to lower it into the container here. Oops, hopefully. Oh, maybe. Yes. There we are, made it. So this is now in the very cold liquid, and the water is turning into ice. So, let's have a look at our ice crystals again. So here we have a crystal of ice. In the ordered array that we see here, well, there seems to be lots of space. So as the liquid arranges itself, the liquid water arranges itself, and we get this ordered crystal structure in ice, there's actually quite a lot of space in it. As the ice melts, it takes up less space. And this means if we had the solid ice, it would actually float on top because it takes up more space. Now, this is what's going on here. We've taken the liquid water and we're cooling it down to make the solid ice, but the ice takes up more space than the liquid. But there's nowhere for this to expand because the metal container was absolutely filled to the brim with water. So this means that the pressure is building up inside here, and now it's exploded. Okay. So this is one from an earlier lecture, and you can see that actually this was pretty thick cast iron. Oops, that's the top fell off. Pretty thick cast iron, okay? And it's just the pressure as the water changes to ice that's broken that. And of course, this is very important. I don't know if any of you had your water pipes burst. Water pipes can burst because, again, as the water cools, turns to ice, the ice expands, takes up more space than the liquid, and that can actually burst the pipe. So when the water thaws again, it all comes out.